Brothers and sisters, help me out. We're going to do a little bit of algebra here. We're going to talk about the absolute value function, something that you've probably seen and used for quite a while. Now, graphically, we know that looks like a giant V, or depending on the transformations, maybe it was reflected or slid somewhere. But essentially, it's a V. There's a pointy bit there. The vertex is at that corner. It's not differentiable there, but it is continuous. So my first question is, where is the vertex on this graph? Where would it be for this particular function? If you said that vertex was at positive 3 halves, you are absolutely correct. Whatever is going to make that absolute value equal 0, that's going to be the turning point. But did you know this little fact about absolute values? If you eliminated the little symbols on the sides, that just looks like a line, 2x minus 3, which coincidentally it is. On the right-hand side of that function, it is the line y equals 2x minus 3. Imagine, what would be the equation of the line on the left-hand side, the part where it's going down? I didn't write that beautifully, but it is negative 2x plus 3. It's the exact opposite, just change the signs. Which leads us to this little bit. You can actually write any absolute value as a piecewise function. Oh, whoops, did that the wrong way. So it's the exact same function. If you're a little bit bigger than the vertex, and it's the opposite of that if you're anywhere to the left of the vertex. Now, at one of these points, you probably have to put an equal sign just so we know something happens at 3 halves. But that is how you can write an absolute value as a piecewise function. Flash forward. Now you're in calculus class, and you get a definite integral of an absolute value. Who'd have thought? Well, here's what you can do. Actually, this is what you should do. Find out where the vertex is for this particular function. You know that the integral is just going to be 4x plus 1 anywhere to the right of that. If you guessed the vertex was at negative 1/4, you are correct. Now we have to figure out, well, what do we do for the other part, everything to the left of there? Easy enough. All we have to do is take the exact opposite function and find the integral for everything to the left of that vertex. We're going to split up an absolute value into 2 parts, and both of them are pretty easy. We'll integrate both of those. Then I'll plug in the numbers. Upper limit minus the lower limit. Upper limit minus the lower limit. Then it's just a matter of math. And there you have it. That seems pretty easy. Did you know you could have done that geometrically too? You can look at the actual absolute value, you know where that's at, and you even know what the function is. 4x plus 1 on the right, and negative 4x minus 1 on the left. Find your height here. That seems to have a height of 7, and this seems to have a height of 21. Then find the area of the 2 triangles. Hey, by the time I plug it in, I get 61.25, which lets me know I absolutely cannot add over here. Positive 1/8 and positive 1/8 is positive 1/4. I didn't really mean to do it 2 ways to check my answers, but it was a good thing that I did. I don't care whether you do it geometrically or whether you write it as 2 separate integrals. Either way is a good way of finding the integral of an absolute value. And when you just realize it's just 2 lines, it really isn't that difficult to do. It's just a little more time consuming. That's it for absolute values. Thank you, and I'll see you in class soon.